Hello everyone, this is Anishu and in this video I'll be demonstrating you a backend combined with a basic frontend for an art gallery of Australian Aboriginal art. Since this is just a basic version of the backend service, I'll not be implementing a API that covers all the possible usage for the art gallery. I'll just show some of the possible bounded contexts that I will be implementing here. Before explaining the structure of my backend service, let me tell you about the tools that I have used to make this project. For the backend service, I have used ExpressJS along with MongoDB for the database. For the frontend service, I have used EJS. Since this video is mostly about the backend service, I will not go into deep details about the frontend that I have created. I will only give you an overall view of how my frontend works and connects to my backend. Coming to why I have used ExpressJS to build my backend. ExpressJS is built on top of Node.js, which has a vast ecosystem of modules and libraries available via the NPM, that is the Node Package Manager. This extensive ecosystem allows developers to easily integrate various functionalities to their web APIs. Not only that, ExpressJS has a large and active community of developers, which means there are plenty of resources, tutorials and community-driven modules available to assist new developers like myself. Hence the reason for me to use ExpressJS. Now coming to why I have used MongoDB, a NoSQL database rather than any SQL database in my backend. MongoDB does not require a predefined schema, allowing for dynamic and evolving data structures. Along with that, MongoDB's JSON-like document format is more natural for developers to work with, especially for applications with complex data structures. Its query language is also intuitive and expressive, allowing developers to perform a wide range of operations with ease. Finally, since MongoDB uses JSON objects, it reduces the need for complex mapping between database objects and application objects, simplifying the ORM process. Also, MongoDB is extremely easy to set up and use. These are the reasons that I have chosen MongoDB for my database. Finally, coming to the architecture of my backend service. At the heart of my system lies a user schema that captures essential user data for facilitating the authentication service. Adjacent to the user schema, I have an artifacts schema that is designed to store image-based works of art. To complement the artifacts schema, I have created another schema, namely fact, which is tailored for textual content, that is facts that the users post. I have created an interactive platform across both the schemas, as users can engage with each other through likes and comments, and that's it for the architecture of my backend service. Of course, my approach to design this backend service is highly modular, as I want to upgrade this service into a much more complex one in the future and add new features to it. Now let's begin the code explanation for our project. Let's begin with the explanations for the models first. As you know, I'm using the MongoDB database, hence we will require the Mongoose library to use the MongoDB specific functions. Let's start with the user model. Here we define essential user attributes like username, email and full name. We are leveraging MongoDB's schema flexibility to store user posts and facts as arrays of object IDs, enabling efficient querying and relationship management. Next up, we have the artifact model. This schema represents image-based posts contributed by the users. Each artifact contains image text, image URL and user reference fields. Comments and likes are stored as arrays, fostering community engagement and interactions. Lastly, coming to the fact model, similar to the artifacts, facts allows user to share textual content. Facts consist of fact text, user reference, and timestamp fields. Comments and likes are stored using same schema as artifacts, promoting consistency across the post types. In summary, our application's backend architecture revolves around these three key models: users, artifacts, and facts. With that, the explanation of the models is complete. Now let's proceed further. Coming to a middleware that I have configured, that is Multer, for handling file uploads in Node.js application. Multer is set up to save the uploaded files to ./public images/uploads directory on our server and generate unique file names using the UUID library. Now you might wonder why my backend database isn't storing the actual image files, despite storing the image as a string in the database. Let's dissect this. In our database schema, we are storing the image files metadata, such as the file name, as a string. However, we are not actually storing the binary image data in the database itself. Instead, Multer handles the file upload process by saving the image files to our server's file system. We then store the name of these image files that are changed using the UUID library in the database. So when we retrieve an image from the database, we are basically fetching its metadata, that is the file name or the path. The actual image data resides in the file system and not in the database. I have used this approach to store images because I didn't know how to create image blobs before and didn't have the time to look into it in details. But in the future versions, I will be storing the actual images into the database directly. Now coming to the connection.js file. In this file, we are basically writing the logic to connect to the MongoDB database. Here, we first import the Mongoose library that provides the tools for interacting with the MongoDB database. Next, we define an asynchronous function named connect to MongoDB that takes a URL parameter representing the connection string for our MongoDB database. Within this function, we use the Mongoose's connect method to establish a connection to the specified MongoDB database. The connect method returns a promise, so we mark the function as async to enable the use of await for handling asynchronous operations. Finally, we export the connect MongoDB function from the module so that it can be imported and used in other parts of our application. Now it's time for the explanation for the controllers that I have created. First of all, coming to the user controller, where we find function responsible for managing various user related operations. First up, the user profile. This function is essential for rendering user profiles page. It retrieves the user's data from the database, including their posts, facts, and renders the profile page with the user's information. Next, register user. This function handles the registration process for new users. It validates user inputs, checks for existing usernames, and creates a new user account if everything checks out. Upon successful registration, users are redirected to the profile page. Moving on to the search. This function enables users to search for other users by username. It takes a query parameters from the request and performs a case-insensitive search in the database, returning a JSON array of matching user objects. Now, the get search. This function renders the search page, allowing users to perform searches. If user is authenticated, their data is passed to the view for enhanced functionality. Last but not the least, user. This function retrieves user data by user ID. It's used for fetching user information when viewing another user's profile. Next up, let's explore the artifact controller module. This module handles operations related to artifacts, the image-based post in our application. Starting with upload post, this function is crucial for uploading artifacts. It saves the uploaded image to the server, creates a new artifact object in the database, and associates it with the uploading user. Then we have explore artifacts. This function fetches all the artifacts from the database and renders the artifact page where user can explore and interact with them. Continuing with the toggle like post, this function allows users to toggle their likes on artifacts. It updates the likes array in the artifact object based on the user's action. Then the delete post. As the name suggests, this function deletes an artifact. Going further, the read post function is used to read a post, that is an artifact. The post comments function is used to comment on an artifact. The like comment function is used to like the comments that are done on an artifact. And that's it. With this, the explanation for the artifact controller is also complete. Finally, coming to the fact controller, which is kind of similar to the artifact controller. This module handles operations related to facts, the textual posts in our application. Beginning with upload fact, this function enables users to upload facts. Moving on to explore facts, this function fetches all the facts from the database and renders the facts page, allowing users to explore and engage with the textual content. Next, the toggle like fact. Similar to toggle like post, this function allows users to toggle their likes on the facts, updating likes array in the fact object accordingly. Continuing with delete fact, just like delete post, this function deletes facts from the database, ensuring content management consistency. Next, the read fact. This function retrieves the specific fact by its ID. Moving on to fact comments, this function is used to add a comment to a fact. Next, like fact comment. This function is used to toggle like on a fact comment. And with that, the explanation for the fact controller is also complete. Finally, with this, the explanation of all the controllers is done. Now let's move on to the authentication handler. This module is responsible for handling user authentication and authorization. First up, render register. This function renders the registration page, allowing users to create a new account. It also passes any flash messages to the view, which can be used to display validation errors or success messages. Next, render login. This function renders the login page where existing users can log into their accounts. If there is an error message stored in the flash, it is passed to the view to inform the user of any login issues. Moving on to the logout, this function logs out the currently authenticated user. It invokes the logout method provided by the passport.js to remove the user's session, then redirects them to the login page. Next, is logged in. This middleware function checks if the user is authenticated. If the user is authenticated, it calls the next function to proceed with the request. If not, it redirects the users to the login page. With this, the explanation of the authentication logic is also complete. Finally, let's take a look at the routers that I have created for this application. First of all, let's start with the user router. This router handles the user-related endpoints and direct requests to appropriate controller functions. We have routes for registering new users, fetching user profiles, searching for users, and more. For instance, the /register route is responsible for registering new users utilizing the register user function from the user controller. Moving on to the post router, which manages endpoints related to the artifacts, the image-based post in our application. Similar to user router, this router directs requests to the corresponding controller functions. Here we have routes for exploring artifacts, uploading new artifacts, liking posts, and post comment. For instance, the /upload route utilizes the upload post function from the artifact controller to handle the upload of new artifacts. Similar to the artifact router, that is the post router, we have the fact router, which manages the endpoints related to the posts, that is the text content in our application. This router redirects the request to the corresponding controller functions as done by the user router and the post router. Here we have the routes for exploring facts, uploading new facts, liking the facts, and posting comments on them. For instance, the upload fact router utilizes the upload fact function from the fact controller to handle the upload of new facts. With this, the explanation of all the routers is also complete. Now let's go to the app.js file and learn how it serves as the entry point and the central configuration file for this project, and how every file that we have created till now are culminated here, and it starts our backend service application. Now coming to the code explanation of the app.js file. At the beginning of my script, I have some setup tasks. I have loaded the environment variables using .env, a tool for managing environment variables in Node.js applications. Next up, I have imported several dependencies such as Express and other middleware modules like Cookie Parser, Morgan for logging, and Express Sessions for managing sessions. One crucial piece for this application is my database connection. I call the connect MongoDB from my custom dbconnect connection.js file that I have explained earlier to connect to the MongoDB using Mongoose. Now let's talk about our routers. We have got 4 of them: auth router, user router, artifact router, and fact router. These routers are responsible for handling different types of requests. For authentication purposes, we employ the passport, a middleware for Node.js authentication. We configure it to use our local strategy, meaning users can log in using their username and password. Moving on to the middleware setup, we configure the Express to use various middleware functions such as Express Session, Flash for displaying Flash messages, and Passport for authentication and session management. We set up our views directory and the view engine to render dynamic HTML using EJS. Static files like CSS, JavaScript, and images are served from the public directory. This is basically the front-end part, and I will not be going into details in this. And then we have the routes. We define the routes for our application, directing requests to the appropriate routers based on the URL path. In case a router isn't found, I have set up a wildcard route to handle the 404 errors, rendering custom page not found view. Last but not the least, when I start my server listening on a specified port, once the server is up and running, it prints a message indicating its status. With that, the explanation for the app.js is also complete, and thereby completing the explanation of the entire backend service. Now, coming to the overview of the front-end that I have designed. All the files that are concerning my front-end are in the views directory, with static files such as the CSS and JavaScript in the public directory. The front-end that I have designed provides a user-friendly experience with intuitive navigation and visually appealing interfaces. Users can easily register and log in thanks to the streamlined authentication system that I have created. Once logged in, they can explore and interact with various features such as uploading artifacts, sharing facts, and connecting with other users through comments and likes. The front-end is responsive, ensuring seamless experience across desktop and mobile devices. With this, the overview of the front-end is also complete. Now let's run our application and see our application in running. As you can see, after starting my application using npm start, The server is started at the localhost 3000 and it connects to the database using the connection string provided in the .env file. After the connection is established, it shows database connected. Now I can explore my application using the link that is provided. As you can see, this is the register page that I have created. But we will not register with a new user first. I want to show you the login page first. This is the login page. Before proceeding further, let me show you the MongoDB database that has been automatically created when I run the code. In my MongoDB database, namely Art Gallery DB, there are three schemas. That is the artifacts, the facts, and the users. In the users, there are already two users that I have created. In the facts, there are several facts that I have uploaded. Similarly, in the artifacts also, there are several artifacts that I have already uploaded. Now coming back to the application, let's log in with the already created user first. After we are successfully logged in, we will be redirected to the user profile page. In the user profile page, there is an option to upload posts, either artifacts or facts. And below that, you can see the uploaded posts, that is artifacts or facts that have been uploaded by the user. Now let's upload a new fact and check the changes in the database. Similarly, let's upload another artifact and see the changes in the database. As you can see, after the uploading of a fact or an artifact is complete, it can be shown below under the user profile. Let's click on the artifacts tab and we can see all the artifacts that have been uploaded by various people. Similarly, in the facts tab, we can see all the facts that are uploaded by different people. We can either like, dislike, read more and then comment and post comments, and we can also like the comments and dislike the comments as well. Same features are also present in for artifacts. We can also see the search feature where we can search for other users by simply searching their names in them. After we search for other users, we can see the uploads that have been made by the other user, including the facts and the artifacts that have been uploaded by that user. Now let's log out and log in with a new user. After logging in with a new user, you can see that the profile page is empty as the new user has not posted anything yet. Let's post some things and check the changes in the database as well as our applications. After uploading some posts, we can see that there are changes in all the tabs, including the artifacts tab, the facts tab, as well as the profile tab. We can see that the new artifacts are added, the new facts are also added. We can also see that we can interact with other people's posts, and we can also see that the search feature works seamlessly. With this, the demonstration of my project is completed. I hope you enjoyed my video. Thank you.